Alcohols! You may not know it, but you rely on them pretty much every day, especially if you live up in Canada, where it's cold 13 months of the year. They're in your car, in your makeup, and in your drink at the end of the day. They're everywhere! Joe Tran.
The science.
Man. When it comes to alcohols, first, you gotta understand organic chemistry. For our purposes, I've got these interlocking things right here. One of these has a C on it with 4 holes, and the other has an H on it with 1 hole. If you haven't guessed yet, these are our carbons and hydrogens, which is what makes up organic compounds. The most basic organic compounds are the alkanes, saturated hydrocarbons. Saturated means they only have 1 bond. Alkenes happen when you throw in a double bond, and alkynes when you throw in a triple bond, but we don't need to worry about those. Why? 'Cause alcohols are saturated. Oh. So now, let's grab some C's and H's. Oh, whoops. Sorry for that hiccup. Did you get it? Yup. Did ya? Mm-hmm. 'Cause it's an H and C going up? Gotcha. We can start chaining them together like your mom's jewelry from back in the day. Take 1 C, stick on a couple H's, you've got yourself methane. Take another C and more H's, and that's ethane. You can keep adding these C's for a while, but the thing about these H's is that they can be removed. Give me a sec. Take aim, and there it goes. Now we can replace it with something called a functional group. And because we're talking about alcohols, we'll stick an OH in there, or a hydroxyl group. Now, let's squish all of those C's and H's into a single block, and we can call that R. That means the general structure of a formula is ROH. Now, if we were talking about aldehydes, that'd be a CHO. If we were talking about carboxylic acids, it'd be COOH. But we're not. Which is why these blocks come in handy. Sometimes things can mean more than one thing. C2H6O is both an alcohol and an ether, but their blocks, structural formulas, are completely different. There's 3 different kinds of alcohols. Let's say we've got a formula of R to CH2 to OH. That's a primary alcohol. Now if you start sticking more R's into the CH2, you add more branches until it looks like an insect of some kind, but truly you can only go up to 3 R's because of electrons. But if there's 2 R's attached, it's a secondary alcohol, and if there's 3, it's tertiary. What I've got here is a beaker of methanol and a beaker of decanol. The methanol has a carbon chain of 1, whereas the decanol has a carbon chain of 10. Now, let's hop in the methanol. That's weird. It looks like the alcohols are bonding, kind of like water, and hopefully like my new brothers. Whew. And that joke was heavier than a black hole. Anyway, like water, the alcohol is undergoing hydrogen bonding. Let's take a peek over at the decanol. It looks like the carbon chains are attracted to each other too, which is weird since everything should be stable. But that's because of the van der Waals forces, specifically the London dispersion forces. We can only predict electrons and their positions. Sometimes they may be so random as to make one side of an element slightly positive and the other slightly negative. These random dipoles attract the long chains together. The longer the chain, the higher probability for random charge switching. This explains why, when alcohols have a longer carbon chain, they also have lower solubility and higher boiling points. There's more C to dissolve, but the C also bonds better to other Cs, making it harder to separate with added energy. And of course, by C, I mean our good friend carbon. Behind me, I've got 4 important alcohols. Here's one I've already gone into. Literally. Methanol is used in fuels and antifreeze because of its miscibility and its use as a solvent for things water can't dissolve. It's also used in the production of formaldehyde. Here's ethanol. It goes in our fuels too. It's a greener option. It's also in our drinks. It's the only drinkable alcohol. This is propan-2-ol, also known as rubbing alcohol, useful for lots of things. And this is ethane-1,2-diol. It's another antifreeze component and helps manufacture polyester threads. Look here, kid. I'm Toe Dran. I gotta explain something complicated and headache-inducing. Something that Pansy Joe could never explain without all his smiles and flowers dying forever. You want to name alcohols? I'll help you name alcohols. You see this beast? We call it 6,8-dimethyl-3-decanol. I'll help explain. See, you get the dec from the longest carbon chain. In this case, it's 10. Here's a handy-dandy table to help. Oh, wait. You need this one, don't you? It goes from 1 to 10. It's simple. Capiche? Anyways, you got 10 carbons. Then, you number them from the end closest to the OH functional group. Then, start labeling the branches. 6,8-dimethyl? That means on the 6th and 8th carbon, there's a methyl group attached, which is just CH3. You gotta put di if there's 2 branch-offs. Try if there's 3, and so on. Finally, you got your 3-decanol. We already got the dec out of the way, and we know the 3 refers to the all of alcohol. Remember that table? When you're working with alcohols, drop that E and put an all. So that 3 must mean that the alcohol is attached to the 3rd carbon. Boom, that's your molecule. There's other crazy rules too, where if everything's connected, you gotta add cyclo, and adding an extra E's in the names when you add dyes, but those don't matter for now. I gotta leave. See you around, kid. Well, I had no idea that was going to happen. It's not like this is scripted at all, and it's not like I'm a fake, crappy cartoon.